Hello, welcome. So for this video, we're going to continue the Zigling exercise. This is part 7 of the whole series. So in the last one, in part 6, we have gone through all the way to exercise 57. And so in this stream, as always, we'll try to keep it about half an hour, and we will work on quiz 7 and then see how far can we continue to go. So as you probably know already, well, this is a exercise. We're doing the Zigling exercise from red factor, and so it contains spoiler, so spoiler alert over here. And if you are watching this video, you feel free to go to, I will encourage you actually to go to the GitHub, fork it, and try to do the exercise together, or in the middle, when I try to work on the answer for each of the exercise, I will pause a little bit so that you get a chance to stop the videos and try it out yourself. So without further ado, let's get started. All right. So what we have here is let's work on exercise 58. So this is a quiz, the 7th quiz, and so I would assume it would take a little bit longer, but let's go. So we have absorbed a lot of information about the variations of types we can use in Zig. So we have a scalar value, a pointer, and size, and array, and pointer to array. Right, many item pointer basically it is a pointed array, enum. And so error, and then union. And how about also it should I mention optional over here, because I would feel that is also a critical piece of the language, because the error, right, as explained before, the error type, well, yeah, that's right, yeah, it mentioned down over here. So create a error union or optional type, so that's fine. So value of any of the above type can be assigned as var or const to follow or to allow or disallow changes. So makes sense. And then also one thing is for the const, this is a compiled language. This const is really meaning is constant back into the language, or back into the program. So we could also make error unions or optional types of any of the above. Actually, give me a second. Let me do a little bit adjustment. Yeah, let's keep it like that. Okay, so the value disallow, we can also make error unions. Yes, knowing all this maybe help out a local permit. Okay, he made a little Zig program to help him plan his trip through the woods, but it has some mistakes. Note about this exercise, you do not have to read and understand every bit of this program. It's a very big example. Feel free to skim through it and just focus on the few parts that are actually broken. Yeah, we can do that, but at the same time, we will try to explain along the way to try to learn the most out of it. Right, so the trip error, there are two kinds, is either unreachable or eaten by a glue. What is a glue? Oh, okay, it's a kind of monster. Okay, all right. Let's start with the places on the map. Each has a name and the distance of difficulty of travel. Have a name. Has a name and a distance or difficulty of travel judged by the hermit. Note that we declare the place as mutable over here, down here, because we need to assign the paths later. So here is the path, right? Why is that? Because paths contain pointers to places, and assigning them now would create a dependency loop. Oh, okay. Right. Right, so you first declare it and then assign the relationship, so that's okay. But here it doesn't mention the distance or difficulty of travel as judged by the hermit. So we'll see. So let's create the map. So here I have the nicely drawn map over here. We will be reserving memory in our program based on the number of places on the map. So there are 6 places. Note that we do not have to specify the type of this because we don't add of this value because we don't actually use it in our program once it is compiled. Okay. So I think maybe this is something that the compiler will do in terms of a optimization, but I wonder how. Well, it's obvious if you declare the size, you know, say use 18. What is 18? Unsigned 16, then you tell the compiler that it's a 16-bit. However, you know, this is as a literal. Well, the compiler should be able to figure that out, right? And yeah, it's just storing a value, so it should able to pick the right type. In this case, should be a unsigned 8-bit. All right, it's unsigned byte. So now let's create all of the path between sites. A path goes from one place to another, has a distance. So okay, that's the path. So from and to, and then by the way, if the foreign code seems like a lot of tedious manual labor, you're right. One of 6 killer features is letting us write code that runs at compile time to automate repetitive code, much like macro in other language, but haven't learned that yet. Right, so that is one interesting thing for sake, that the language itself, it doesn't have macros, but you're still able to do compile time programming, right? So that will be covered in the comp time down below in exercise starting from exercise 66. Right. So I always forgot to turn this on. Okay. All right, so now we are setting them. So from A to B. So this just set all of the distance. So we assume those that's correct, right? What's important is, well, one thing to point out is this is the length of the array. This is an array. Right, so the size, the length of the array is fixed and determined at compile time, but we are using this syntax to infer it, right? To tell, hey, compiler, just figure this out for me. Right, so that's that. So once we spot the best course through the woods, we will make a trip out of it. A trip is a series of places connected by path, okay? We use a trip item union to allow both places and paths to be in the same array. So basically it's the dot, words, and the line. Well, the dot is the places, the line is the path, and you have this trip item allow you to indicate, are you on the point or are you going through that path? Right. So that's that. So we create a tag union, right? We learned that from the last exercise. And it's automatically inferred the elements in the enum, which are this place and path. And in this case, we also create a helper function, right, to print the two different path in two different type of item correctly. So self is a trip item, so it's this guy, and we can use it as a enum. So that's why we can do a switch of self if it is a place. Then if we get the p.name, if not, we have the distance, right? So the Hermit's notebook is where all the magic happens. A notebook entry is a place discovered on the map along with the path, right? Along with the path taken to get there and the distance to reach it from the start point. If we have, let me do this. It's taking that from, if we find a better path to reach a place, a shorter distance, we update the entry. So entry also serves as a to-do list, which is now we keep track of which path to explore next. Right, so that's fine. So that's where you are, where the places, where you are, where you are coming from, which can be null, because it's so it is optional. So where you come from via which path, right? And this to reach. So what is this to reach? Is it the total distance or what? And over here we have the distance, right? Or this is talking about where you're going. Okay, let's read it one more time. The Hermit notebook is where the ordinary notebook entry is a place discovered on the map along with a path taken to get there, and the distance to reach it from the starting point. So it's cumulative. Okay, if we find a better path to reach a place, a shorter distance, we update the entry. Okay, so basically we try to create a map to figure out, okay, for each place, where can you get from, which is the shortest distance. So just keep track of that list and update it along the way. Okay. So in the Hermit's notebook, for example, one entry is the place is the archer point. So the place is this. It's from now. That's the starting point, right? So the distance is 0. And then the next entry over here is the place is bridge, right? Coming from is archer's point via path, and there is a specific path. The path doesn't have a name, doesn't it? Yeah, it's just to and from. Right, and this path is dictated by the place and coming from, I guess. No, not actually. Yeah, it is, because it doesn't make sense to keep the original one, because the coming from is always the last place that you just visit, right? Not the original one. 1, because if it is original one, it will always be the archer's point. Okay, and then let's just keep track of the total. But here, this is 1. What does it mean? This is the wording is a little bit confusing, because this distance, I hope it's not assuming this value, because that should be the distance between the dogwood grove and the bridge. So if we go look back up here, the which is between B and D, right? So if we look for B and D, right, from, well, where we're going from and where we're going to, so it's coming from bridge to the dogwood grove. So from bridge over here, so from is B and D is where it's going to. So I assume it's in the B's path. So from B to D, the distance is 1, right? So that is the distance, that is the value inside this path, right? Not the total. Okay, so it's not really this. So that's why there is a slight disconnect between the two. Okay, but knowing that, let's continue. So remember the array repetition operator. So that is a multiplication. So it is no mere novelty. It is also a great way to assign multiple items in an array without having to list them one by one. Here we use it to initialize an array with null values. So basically multiple this by n times, right? 6 times in this case. And to create a array and initialize all with null. Yes, you know, in the previous video, I mentioned that, you know, it is interesting to take this approach, and yes, you can use this feature, you know, use this syntax over here, but I'm wondering, is that necessary? Because, well, for this specific use case, there are a lot of different ways to do it, right? You can initialize an array by really just creating an array and specifying what is the default value to put in. Essentially, that's what it is doing here, but it is using a kind of a little bit lower level mechanism to do that. Still don't know. Maybe, well, of course, I'm not to judge the how it is done in Zig, right? I'm just thinking about, if I am designing a language, would I go this path, right? Go this path to do the array initialization this way. Yeah, because doing it like this, let's see. This is number one is a very specific way to initialize array. I know that yes, a lot of time that's what you want to do, right? You want to create and initialize an array with null or with certain values, or even in a repetitive sequence. Say, for example, this is 1 and 2, and then you just create a long array from 1 to 1 to 1 to 1 to, and putting them together, right? So it is possible by this construct, but I just wonder, is that's the best way to do it, right? But that's just my thought. Okay, so the next entry, keep track of where we are in our to-do list. Okay, so it's over here. Right. So this is, and then also over here you see that it initialize or in this case, really declare the type. It's an array with length 6 with 6 elements in it, and it is a optional notebook entry. Right. So mark the start of empty space in the notebook. Okay, so where the new page is. We will. But why I only have 6? It have 6 places. Okay, that doesn't match with this at all. Because I was thinking if they were doing it like this, it's meaning you're trying to create a n by n map, right? N square map. Of course, that's not the most efficient way to do so, right? So that you can describe all the place, the distance, and of course you can. And I think the program will do is update the subsequent places, the notebook entry. Towards the address point, so that you get the total distance along the way, and that's one optimization. So in that case, then that makes sense, right? And so this is really when they compare to this table, this just set the value to this 2 or 1 as the initial value, which you will change along the way. Okay, so we will often want to find an entry by place. If one is not found, we will return. Or because it have not defined yet. I see. It is not defined yet. That's why. Okay, that makes sense. Right. So it get the self, and then it try to look for a place, which is a pointer. And so it goes just try to iterate through the entries over here. It can be optional, right? And we are doing this manually to make sure that we are not going outbound. And then we just try to get the entry, and then try to extract it from within the entry to get the place and see if it's the same. Then we return it. So here here's where the Hermit got stuck. We need to return an optional pointer to notebook entry over here, right? What we have with entry is the opposite. It's a pointer to an optional entry. That. Right, to get from one another, we need to dereference the entry. Right, so here we dereference it, and to get the non-null value with the optional, this part, right, and return the address of that. Return the address of that, yes. Yes, the if statement provides some clue about how the dereference and optional unwrap looks together. Remember that your return will return the address with the so just a very short one. So basically, is returning that. Oh, I forgot to tell you to pause. Right, so I hope you did. But of course, this might not be the right answer. We'll see. Right, so let's well, what's it? Let's take a look. Yeah, I go through the other one. So this looks fine at the moment. But until we actually run the whole thing, we don't know. So let's fix the other compile error first. So the check note method is the beating heart of the magical notebook. So probably down here, check note. Given a new note in the form of notebook entry struct, we check to see if we already have an entry for the notes place. If we don't, we will add the entry. Yes, if we do, we check if the path is better. Right, if it is, we overwrite. Okay, makes sense. So we get a new notebook entry. And then over here, we are trying to get the entry. So this is of type, it should be of type optional pointer to the notebook array. I don't know why this is showing up as an unknown. So supposedly that is that, and yeah. Interesting. So somehow this is marked as unknown, but that's fine. So if we say if it is null, then we will use this to set the node and increment it. And then if the node to reach the input is shorter than the existing entry optional, unwind the optional, extract the value is less than that, then we put the node into the existing entry. So that is the notebook entry, and that is the pointer. Yeah, I would be a bit confused about this. Yeah. So this extract the say it is non-optional, so it gets to the non-optional block as mentioned. Is really is a union. Right, so it gets to that, and then that the pointer. Because I would think about something like that, but not writing it like this. But well, it is what it is, but this does take some time to use to. This feels strange to me. Maybe I need to start going back to some previous exercise to understand, right, why it is done this way. So the next two methods allow us to use the notebook as a to-do list. Has next entry. Right, it returns a boolean. That's very straightforward. And then get the next entry, and so this we will get it and also increment it after the return. Well, so basically these two functions combine to so that we use this struct as an iteratable, right? And of course with this next entry. So that's what it is. So if it's in Rust or another language with a traits mechanism, then this will go to the iteratable traits, so that it won't get everything in here. But I don't know if there's some traits mechanism. I don't think so in SIG, right? But if it does, some kind of interface, things like that, then these and also these two functions would go into the other the interface or traits, right? So that's that. Because when I look at it, I get a double tick on this, because the first thing I think of it, is a mutable state, right? Well, of course, this is a struct and you are mutating it, but you are calling a function, especially on this one. That's what I focus on. On this one, you are trying to get something, and then at the same time you're iterating, you're incrementing, moving the pointers along. So the struct essentially becomes a state machine. And that is actually something interesting to talk about a little bit, right? So the topic is about whether, what is functional programming, right? In functional programming, we talk a lot about pure function and impure function, right? And we prefer to have pure functions, but at the end, when we still need to interact with the outside world, right? Say taking some input or printing some outputs, right? And those cannot be pure, right? Because by definition, you are changing the state on your screen, right? You are printing out something, or you're taking in some inputs. So those has to be impure, and that is typically where, in those in a lot of the tutorials for functional programming, that's where it stops, right? They say, okay, you write pure functions, and then you have some impure functions to interact with the outside world. And then, of course, later on you can talk about the monads, which allow you to make the function still pure, but with side effects. But still, the example is about that. However, at the heart of the functional programming, right, it is not really just between pure versus impure, and the impure function is not really just the outside world, right? And the iterator, these iteratables is actually the heart of functional programming, and they are impure by definition. So say, for example, you have a function, right? You let's say increment, right? And then you say it's a range of from 0 to 100, right? And then in the functional programming, it will talk about iteration is lazy evaluation and things like that, so that this is a iterable, so and it's lazy evaluated. So every time the echo is called, so the echo call the increment, and the increment call the range, and so that it will just return 1. So in fact, you can make a range, infinite numbers, right, from 0 to infinite. And in functional programming, this still works. And my cam just died. So give me a second. So we will continue without the camera. That's okay. So we talk about back to here. It talk about lazy evaluations, right? And it will just work. However, if you look closely, right, the range, the fact that it's lazy evaluated, and every time you call it, you get a different answer, is impure. But that's what impurity means, precisely what it means. So that's something that I always feel a little bit intimate, irritated by how functional programming enforce and promote the paradigm, right? Not to say that I don't like functional programming. I love functional programming, and do try to convert more and more of my code towards functional programming, right? I think it is a great paradigm, especially nowadays with the multi-core mechanism, with the multi-core environment and multi-threading and so on, able to do functional programming and spread it out, is a huge advantage, right? So no problem over there. However, I don't think we should sugarcoat it as much as some of the tutorials seems to portray, right? So yeah, so that's a little bit rant about how how people describe what functional programming is, and this is one point to be pointed out. Okay, anyway, let's continue. After we have completed our search of the map, we will have computed the shortest path to every place. To collect the complete trip from the start to the destination, we need to walk backward from the destination notebook entry. Yep, so following the coming from pointer back to the start. Yeah, so that makes sense. So what is meaning is after you filling all this in, have the six entries. So then you look at your target, and then from the target, because this is already optimized, right, it will get the distance, the shortest distance. So then it will just return, just going to the from part, and then just iterate all the way until you reach the beginning, which the from is now, right? So now, yes, now this makes a little bit more sense. This distance to reach is the distance to reach from the coming from to the place, right? It's just that the distance to reach depends on how you traverse the path, right? Over here, say for example, from the let's say from the east point, well, I really should say from the Dogwood Grove to the east point, right? You might go from here to the boat. I don't know if there's a boat. Maybe, yeah, then there's no boat to the east point, or from the bridge to the I said it wrong, right? Say from the beach to east Dogwood to east point, or from bridge to cottage to east point. So when we look at this one, we will see, okay, no, that doesn't make sense either. What I really want to say is from the Dog Grove, you can go to cottage first and then goes to east point, or you can go straight from there to here, and the distance maybe going from here to here is actually shorter than go straight from Dogwood Grove to the east point. No, maybe I just choose the wrong example, right? But you get the idea. When they try to transverse it, if it's shorter to go from one place to another, then it will update the path. So it's a bit wonky the way I describe it. Anyway, let's continue. Go back all the way up here. Following the coming from pointer back to the side, yep. So we need to take the trip array as a parameter because we want the main function to own the array memory. What do you suppose? Huh? What is trying to say here? What do you suppose could happen if we allocate the array in this function stack frame? Or what do you suppose could happen? The wording is a little bit trip me up a little bit. But I think that's okay. It's just how I read it is confusing. So let's see. We're back. Because if the function owns the memory, then that would be a problem, right? Every time the function is called, the memory is called within it, and should be destroyed with it. So it's about memory management. Because yeah, actually, that is something more specific to lower level language, because you have to manage the memory. So what it means is, if you declare over here and just return it, first of all, I don't know if that is possible in C. I don't think that's possible. Well, you can do it by doing malloc, right? However, when you return it, then the outside, the caller will be responsible for freeing the memory, right? That's why it's very easy to have memory leak in C code, because the place that you initialize the memory and the place that you clean up the memory are two different places, right? One is at the consumer, one is the producer. So yeah, so that's that. That's one of the main problem. So by passing it in, then it is the caller who is doing the creation of the memory, and also the caller who is doing the cleanup, right? So the memory management is in one place, so it's much cleaner that way. So give me a second, actually. All right. Look like the hermit forgot something in the return value of this function. What could that be? What could that be? So get trip 2, we start at the destination entry. So that is where we want to go to, right? So this is all the trip item. And then if the destination entry, we cannot find it, or it cannot be reached. Hold on. This function needs to return an error if the request destination was never reached. This kind of error. Is that a right description, right? I'm not saying the program is wrong. I'm just thinking, yeah, so the destination entry is null when there is no entry inside the notebook, right? So just make sure that we are this is the whole notebook, right? We get the entry, we set the entry, this is optional, and the entry contains the place and then the coming from and all that, right? So it does mean that even I was thinking about, okay, the place could exist, but there's no way to reach it. And in that case, what should we show, or what should we contain? One way is doing exactly what the program is doing, leaving it as a null is not added in there. And then another way is saying that, oh, it comes from nowhere. right? But over here, we are saying, you know, from the when it's null, when the from is null, is the starting point, right? We assume nowhere else can go to it. In real life, say for example, if you think about this is a game, right? That doesn't make sense, right? There's no place that you really can go back to, right? Even if you is a two-way like this, right? It's a bi-directional path, right? So you can go from Archer's Point to bridge, but you can also go from bridge back to Archer Point. Of course, yeah, you can say that, okay, it's a game that you start at the starting point and then you just jump off and then you can never go back. Well, yes, right? Yes, that is possible. Right, but in that case, you know, do we really need to have this entry to begin with? Maybe not, right? But however, this is correct, right? The program with this scope, how it's designed, this is correct, because by doing it like this, if the main code try to say, oh, how long is this, or how to get from Archer's Point to Archer Point, then the answer is you do nothing, right? You do nothing. And so it is I'm just moved away. So it is how this is described over here. The distance is 0. But maybe another way I would say, well, yeah, I think this is fine. It is very common. I almost thinking about having an error code that's saying, hey, you are already in that place. But you can also say that you are already there, so it's good, you are fine, right? So it depends on how the code or how the game perceives the value, and this is a much more reasonable way than what I was talking about to having an error, because it's not an error. You are standing right there. That's just, you don't need to go anywhere, right? So so that's that. So that's fine. So let's go down here. So this returns a unreachable, so that's fine. The variables hold the entry we are currently examining and an index to keep track of where we are appending or appending adding trip items. Variables hold the current entry, right? And an index to keep track of where we are appending trip item. Oh, the I on this. Oh, okay. Because this is a slice. Okay, fine. At the end of each loop, a continue expression increment our index. Can you see why we need to increment by 2? Well, I know why, but I pause a little bit to see if you know why. 1, 2, 3. Right, so the reason of that is because the trip item, remember above, the trip item contains both, where's the trip item? Oh, trip item. Yeah, here, right, it is a union. Right, it's either a place or a path. So the trip item actually contain both, right? So when you move from one place to another, you will need to add both the path and the new place. So that's why it's 2. That's why over here, when you increment, it is increment by 2. Okay, so so the trip item, first you start from where you are. Right, and then if it doesn't have a coming from, we reach start, so we are done, right? So yeah, so then, okay, we are done. If not, then it goes via path. So we are tracing backwards, right? Remember, we start with the destination, and we are tracing backward, right? So the via path is the path that goes from B. The original path is the actual trip is going from A to B, but right now we are at B place, and so the via path is where it goes from A to B. So then we get this path, and then we add A. At the coming from. Okay. Now we follow the entry coming from. We are unable to find the entry we're coming from by place. Something has gone terribly wrong with our program. Actually, it shouldn't happen. Have you checked for groups? We haven't yet, right? Hidden by group. This haven't been used anywhere. Note, you do not need to fix anything here. Okay, so if the previous entry is coming from is either so seems like it is doing something and reusing the data structures. So say if the previous entry is null, then it's assumed to be hidden by group, and you say we don't need to fix anything here. You sure? Because here, this is the current entry from. If it is now, we break already. And then, so what's the point for this code over here? I don't know yet. Right, so let's continue. Because right now, at this point, this code doesn't make sense yet. Right, this line does. Right, so we get the current entry to the previous entry. Previous entry is not now. But maybe my guess is this is not really say eaten by a group. It's just that is for the type safety. Because the previous entry, this is a optional value, right? To make sure that we understand, right? This is a optional value, right? So therefore, it could be undefined, right? Although I really not now need to go back and look, because when you are doing this, I thought it means we are already saying that it is not optional. Let me take a look again. So yeah, this is already not optional, right? We are already saying it is not optional. We know it is not. It is the same as or else. Right, this is the same as or else, unreachable. So if it is really null, doesn't have a value, it crashed the system already. Right, it will get to this unreachable, and it will fail. So this code, what you see here is already we're saying that this will not be null. So then why we still need to check this? I don't really feel like we need to check this. Of course, I might be wrong. So let's take a look again. Right, so for the place itself, where's the place? Right, so the place itself is just a simple struct, right? I don't know why it is doing this. This doesn't seem to make sense to me. Right, and then also this also doesn't make sense because we are already hold on. The entry, what I'm talking about, yes, the get entry. So this we are trying to, from this guy, we're trying to get the entry from using this new place, right? We know this new place is not now. Yes, completely messed up. So this is not null, but we try to get the entry of that guy. And if that is null, it's kind of just like the same as here, right? If this is null, then it will be unreachable, right? So I see, now it makes more sense, and now it makes sense. So it's now I know how the program works. So basically you create all. Let me describe that in a moment. Right? I don't want to ruin the exercise. So, but now I get what it tries to do. So here is where the hermit decides where he would like to go. Once you get the program working, try a different place. Okay. So you start from A to F. Why? Well, it's not right. It's just not right. This start doesn't do anything because your program is hard coded to say the A is null, right? And so meaning, yeah, but it is an exercise. Well, first of all, disclaimer: this is an just exercise for you to learn the language, right? So it's okay that the logic of the program doesn't make complete sense, right? That is completely okay. But I'm just saying, okay, as I'm trying to understand the program, what's the problem I see with the program, right? So the issue is that, yes, while you can change the destination to find out the distance or the trips that you will go from point A to whatever that point that may be, and it will return the right value, you cannot do the same by changing the start. In fact, you cannot. Well, it depends on how this is printed out. You might not even, the start doesn't make sense. And you can actually get to an infinite, you can get to a null reference or crash or whatever, because in the data structure itself, it have that archer point, and then it from is null, and using that as indicate to indicate that it's the end of your transversal, right? So that really shouldn't be the case. So the better way to do that, well, before I say the better way, because the data structure hard coded that logic into the data, so you can only start from a place that is where the from is null, right? That is the only way that you can get it working, I think. But maybe I'm completely wrong, right? It could be something completely different, but in either way, the better way to do is to pass both the start and destination, and you go from the to the starting point, or you try to go. You will need to start branching out and see which one go to the starting point first, right? So the logic and the algorithm will be completely different. So that's why it is okay for this exercise is implement or design it like this, and we shouldn't drill too much into it. Okay, so and my oh boy. So that's that. So store each path array as a slice in each places. As mentioned above, we need to delay making this reference so that to avoid circular reference, circular dependencies. So that's fine. So this is initializing it, and in fact, you would normally probably put it over. No, never mind. You can predefine it. That depends on how you write your program, right? So now we create an instance of notebook and add the first start entry. right? So let's we already streamed for about an hour, and there's still some things need to work, not too much. So let's see. Let's finish the description first and then see if we can quickly fix it, or we will leave it to another stream. So now we create an instance of the notebook and add the first start entry. Note the null values. We set it to read the comments for the channel method about to see how this entry get added to the notebook. Okay, so we can go there, just double check, right? We try to get the entry from the place, and then we try to fill in the distance to reach and all that. The note, yeah, why we need to read that? This is just really just adding. Okay. So get the next entry from the notebook, right? So this is we just get the starting entry, right? The distance to reach. So that put the first entry in there, right? The archer's place. Is it called archer's place? Let's see, archer's point. Right, so back here. What? Okay. So while notebook has next entry, what? We haven't added anything yet. That is the only one we add. Why? I don't understand. So if the next entry we haven't iterated yet, and the end of entry is 0. We are just adding one entry. What do you mean? Well, I'm confused. Why we have this loop over here? I am very confused. We just create a notebook, adding one note, the first one, and then we try to loop. So let's assume, let's see past that. Right, for every path that leads from the current place, create a new node. So entry place path for each one. We will check node. Okay, and the key is, hold on. So from I'm lost. This is the place entry on the notebook. You try assuming somehow magically this fill in, right? And then we get the entry, and from the entry we look at the path that where we can go from this place to all other places, right? So we get those paths. And then we create a new notebook entry, right? So say this is A, right? So the path 2 is B, right? And then coming from A, right? So this is the place or the from is the same one, right? Via path, that makes sense. So and the distance to reach from A to B is the distance to reach from this place plus this distance. No, now it's talking about, it's really using the calculating the total. Okay, so this now it doesn't mean the total. It's not the shortest path between the two. Okay. Yeah. So I feel well, let me do that in the summary. Now, once the loop above is complete, we have calculated the shortest path of every reachable place. What we need to do now is set aside memory for the trip, and the Hermes nodes fill in the trips from the destination back to the path. Note that this is the first time we actually use the destination. Yes, because everything before that, you are just analyzing the whole place, right, to create all the path and all the values. So you do it multiply by 2. It's the same reason you are storing both the path and the place, right? The place and the path, right? So that's that, and then you're doing this initializing it. You create a single null value, an array with length 1 contain a single null value, and then multiplied it by place count times 2 to make a 12 length array, all contains null. So yeah, I really do feel like, you know, this is probably a much cleaner syntax to initialize the array, right? This times 2, like that, right? But well, it is what it is. That's how Zig does it. So notebook get trips 2. So it starts from it create a slice, right, and point to the destination. If there's any error, it print out error. If not, it print out the trips. However, there's still a problem, because the get trips to is filling in the trips from the destination to the starting point. So if you print the trips, okay, it makes sense. It's probably in the trip you're reversing the order. Remember, will be a series of alternating trip item content placed from the destination back to the start. Yes, exactly. That's what I'm talking about. The remaining space in the trip array will contain null values, so we need to loop through the item in reverse, skipping nulls until we reach the destination at front of the array, right? So this is the trips. So yeah, no camera is painful. Give me a second. It's up again. All right. So the array, the trip array, right? The whole thing. The first one is the destination or for your viewing. Yeah, this is fine. This is the first destination 0, and then it go all the way to the starting point, and then the remaining is null. Right. So what we need to do is reverse it and then get the the actual starting place, and then print it out all the way to the destination. Right. We convert the unsigned size length to a U8 in incast. Right, because we know that it won't go beyond a unsigned byte. So while it is greater than 0, we'll start from the length. Does it mention this is the array length, right? So if it's null, it is continue, right? So it start from null. Oh, there is the starting point. So it start printing all the way to 0. So that's good. Yeah, so in computer science term, this is talk about graph theory, right? It is the nodes and vertices and the edge and all that. If you feel you're interested, I will encourage to take a look at it, right? This is try to find the lowest cost path. Right, so the Hammett notebook most closely resemble the shortest path faster algorithm. We basically have the Dijkstra algorithm, a priority queue retrieved is sorted by wave. I will take a look again at the algorithm. I feel like there's something off. Maybe it is because of the way it's described, and in this level of programming, it is very common that the programmer, when you're writing this code, you reuse or overload the meaning of the fields inside a struct, right? Because in this level, when you're doing programming, is important to be cautious about the actual memory space that you're using. How much memory space you're using, how you transfer it to get the maximum performance. However, that means that the naming of the fields could get confusing because you are trying to reuse it for multiple purposes. I'm not sure if that's the way over here, but I do have a little bit hard time to understanding it, right? Especially about the distance. Right now I'm still confused from the code. Over here, it does seems like it's get the distance to reach all the way to from the beginning, but the drawing over here on the logic that doesn't seems to make too much sense, right? Because this and also this whole thing only works if there is one single point of source, which is the archer's point, which is null. Right? I think that is the place, and I still don't know how we are adding the entries in here. Or maybe because by running it we will know. Maybe because we are adding the node here, so the first check will be non-null, so it has a next entry, so that kickstart the whole process and doing this. That's what I think. That's probably what happened, and the reason is the reason about the confusion is that over here I already added one, so in my mind we already have an entry with one value, so that when I say it's the next entry, I'm already thinking I start here, but the fact is it is not. Right, so over here, I think that's the case. We are really doing a for notebook and then the entry over here, right? To get the next one, it is iterable. Right, so this like that, it will be much clearer. And my guess is the exercise or the quiz is written this way because we haven't talked about how to do the how to implement the iterable yet, so that's why I have to write it like this, and it's a little bit confusing. I guess that's how it is. So now unclear. So that's it. It doesn't ask us to print to see to change any other code, but here is not right. 192. Oh yeah, I completely skipped it. So print me this is a little help. I will print two different types of items. Oops, the hermits forgot how to capture the union values in a switch statement. Yeah, so it's probably this name. Something like this. So let's just take a quick look. Yeah, like that. Hey, why? Is it like that? So insect is still, oh no, it's A or F. Still alive. Yeah, it is getting the value. Okay, it is getting the value. So the place is P. Alright, the place is P. So it's P tree.name. And then the path is, I would say, also P. And then it's P dot destination. Like that. All right. So 414. Did I change? I didn't change anything. 414 get trip 2. Expect area union type func now. Get trip 2. Oh, it looks like I forgot something in the return value of this function. What could it be, right? So this is returning a trip error, or what's the return value, which is the previous entry, which is wait, come on. Oh, it messed up. It, which is a noble entry, right? We extract it, we know that it is not null. Trip error is written like we go back, explanation mark. Expression value is ignored. Yeah, it's probably, it is a that that's not right. I do So what we return is a pointer, that's for sure, but it is a optional pointer because it we do get null though. No, hold on. Right, we do get null because we are filling the value inside that trip. So why are we returning? Why are we returning? So it should be like this. Oh yeah, we are not returning. So 158, there's still some problem over here. Yeah, now that's where it gets to. Right, expected type, the notebook pointer. But we found that. There you go. There you go. That's it. That's it. Right, so we get the here we get the pointer and then get to say that we extract the optional value, right? Because it will not be optional because we already declare over here that it is not optional, and then we're returning the pointer of it. So all right, so that's it. Let's recap. Right, so the thing we have changed over here, these are just some command change made by the formatter. So just look past that. Right, so this is, we are fixing the switch statement, right? And that's how you would extract the value from the enum. So that's simple. And then to return the right type, which is a optional pointer to an array, we will do this. It's optional because over here it is returning null, right? If you cannot find it. So that's explain the optional. When it is not, when we find it, we try to get that value and just return. Oh, that's what it means. It will be just that long. That's what this command means. Okay, so it's just get the pointer of the extract the value, the pointer inside it, and then makes it extract the optional type out of it, just like here, the optional value out of it. Right, then over here we just change the type to mention that it could indeed fail with certain error, in this case the trip error. And then over here, well, nothing, this is just command code. All right, so we survived the quiz 7. As you can see, well, the change itself is not that much. We spend a lot of time in describing the question, the problem, and we go into try to explain everything about the program. And I also pointed out that this logic, in my opinion, it probably seems wonky a little bit, because as I mentioned down here, when we actually try to use it, let's go to the main, right? We say a start and destination, right? However, when we are trying to get the trip to the destination, right, we never really say that where we start from, right? So the notebook itself assume you start from this A, right, the address point. But in fact, you don't have to. And the whole data structure is designed, and the algorithm is designed to utilize the bomb field is null right over here, to determine that is the starting point, which might not be true in real life or in the real game or whatever code that you're working on. So and then my cam died again. Yeah, and so that's that. And I understand, you know, this for this quiz, right? Red Factor try to create a nice exercise or a nice quiz again with some context to create it, make it more fun, looks like a game doing the transversal of point or of a graph. But if you really think about in the game, right, this might not be what you will actually implement, right? So you learn, when you work on the exercise, right, just have fun, try to solve the problem, but that is not a solution for this kind of problem that you can, you know, copy and paste and try to use it in your own program, right? Don't do that. With that, that's the end of this video. Hope you enjoyed it and hope you learned something. And if you enjoyed this video, well, feel free to add give it a like and subscribe to the channel. And I have a Discord. I have a Discord open. On the top right, on the right side on the screen, I will also add that in the description, so feel free to join and we can talk about programming and gaming, anything we would like. So with that said, that's the end of this video and we will see you next time. Bye bye.